Hi, in this video we're going to be talking about deltaG, which is Gibbs Free Energy. And this will be used to determine if something is thermodynamically favorable, or what we call spontaneous. Thermodynamically favorable process is what we call TFP. And this is a spontaneous reaction, which means it occurs naturally in nature. And now to calculate deltaG, we have mainly two ways. So first is the way that we use for delta S and delta H, is the deltaG reaction is equal to the sum of number of moles times the deltaG in product minus the sum of number of moles times deltaG in reactants. So products times their mole multiplied by their moles of deltaG from the chart that we've been using, and subtract that by our reactants times their deltaG, and that is how you find deltaG reaction, that's how we find the overall deltaG, which is the same exact process we've been doing for delta S and delta H. And now, if deltaG, if this number is greater than 0, that means it's non-thermodynamically favorable, non-TFP. If deltaG is less than 0, that means it is thermodynamically favorable. And our second way of calculating deltaG is that deltaG equals delta H minus temperature times delta S. So the temperature. So as long as you know the delta S, you can, and as long as you know the delta H, delta S, and the temperature, you'll be able to find out deltaG. And same goes here. If deltaG is greater than 0, it's non-TFP. If it's less than 0, it will be TFP. And while using this formula, one thing that you gotta be careful of is that delta S is measured in joules per mole, but delta H and deltaG are measured in kilojoules per mole. So while calculating, you have to convert this convert this delta S into joules per mole, or convert this delta S to kilojoules per mole, or convert everything to joules per mole, and then solve it, and then divide by 1,000 to find deltaG in kilojoules per mole. Oh, sorry. There is actually a third way to find deltaG. In fact, there are going to be more when we go to our next unit, but in this unit, we'll be mainly focusing on this three. So our third way, deltaG, is going to be equal to negative RT ln K. And this is in regards to equilibrium. So our first way to find it if you're only given deltaG values. Our second way is when you have delta H and delta S in temperature. And our third way is when you have equilibrium, the equilibrium constant, KEQ. So here in this part, the R is gas constant, which is 8.314 joules per mole K. Now this T is temperature in Kelvin, and KEQ is the equilibrium constant. And over here, if deltaG is equal to 0, that means the system is at equilibrium. If deltaG is less than 0, then that means K has to be greater than 1, and this means the products are favored. If deltaG is greater than 0, which means non-TFP, then that means K will be less than 1, and reactants are favored. And yep, that's pretty much all you need to know on how to calculate deltaG. In the next video, we'll be doing some more examples. Thank you for watching.